Well, thanks for coming. This is DB Time Basics, Fundamental Concepts for Oracle Performance Analysis. I'm JB, John Beresniewicz, and I'm recently rehired at Oracle after having done 11 years previously and in the Enterprise and Cloud Manageability Group. So I just found out this is a 30-minute presentation, and I probably have much more than that to say, as I often do. So I'm going to just try and go quickly, and hopefully you can re-refer to the slides if I don't sort of address
45 minutes. 45 minutes.
35, yeah. Anyway, okay. We'll get through. Brief agenda, intro, architecture, DB time and average active sessions. That's really the core here, right? And I don't think we'll get through the Perf Hub demo. That demos tend to take a little time. And we'll briefly talk about instrumentation and tools. I'm not going to talk really about this slide because it could take it could be a half-hour interview or something. But I've sort of, my personal history in Oracle technology is kind of, tightly wound up with a lot of what we'll be talking about in terms of products before I joined Oracle and products after I joined Oracle that have to do with analyzing performance in Oracle databases. So, maybe we'll have some kind of a round table about a lot of these historical topics. But basically the point here is, actually there is a point to this slide, which is this is not new stuff, right? The stuff, DB time was sort of a concept that wasn't just born one day, right? It evolved out of lots of prior work on the conceptual and also instrumentation levels. So we'll leave that at that. So when we talk about performance, we commonly think of certain measures or metrics like latency and throughput. And basically performance is really, it's always a function of both work and time, right? In the case of latency, you're kind of measuring how much time it took to do a certain kind or amount of work. And in the case of throughput, it's really just the inverse of that, right? It's like, well, how much work can you do per unit of time, right? And so a couple of key things there, performance is always kind of involving time. And the definition of work, well, that's kind of interesting, right? I mean, time, we have a common notion of time, right? And we measure it in very standardized ways so that we can communicate about it. But work is a little bit more subjective, right? There's lots of different kinds of work. And on the right here, we have a couple of examples, right? So response time is sort of a latency measure. Transactions per second is more of a throughput-like measure, although the meaning of transactions, again, if that's supposed to mean work, well, it kind of begs the questions, what's in a transaction? How much work is there? Let's move on. Oh, so basically one of the big points of the presentation is average active sessions. So, we talk about average active sessions in relation to DB time, and it's really kind of, the most sort of fundamental measure that you should understand relative to DB time. So very simplistic diagram, but anytime we're going to compute with data, well, we involve CPU, of course, because that's computing, and a disk because, or some kind of storage mechanism because data has to sort of persist somewhere. CPUs, at least until memristors become the basis for compute architectures, don't hold data. They don't preserve data. So the data that gets computed on has to come from some kind of storage medium. So basically, the time and these things, computation happens within the context of an operating system process executing, some program instructions. And so, compute happens on the CPU, data comes in and out from disk. And so the process is either working or waiting for data in order to work on that data, right? And so, or it's not doing anything. So those are sort of the three states that we think about in terms of how the computation time breaks down. Excuse me. Okay, simplistic application, a simplistic diagram, architecture diagram here of, a database-centric, let's say, view of application architecture in terms of Oracle database, right? So on the right side, we have an Oracle database, and the work inside a database is conducted by foreground processes. We'll talk more about that. Data comes in and off of disk, compute happens on CPU. And somewhere out there, there's an application, and the application establishes a connection to the database through the network. And that's how it requests database services, which is usually in the form of SQL, right? So the requests are typically SQL and responses are typically, the data that conforms to the result set of the SQL. But the point here is response time is measured somewhere in that dotted box, and DB time is measured here, right? And so that offers a lot of opportunities for disconnect in terms of performance diagnostics and really tracking down problems. But basically, the real point here is database time. We measure it from inside the database, but applications measure their response time from their perspective, right? So DB time, what is it? So kind of a casual definition would be, time spent by the database processing SQL. That sounds pretty reasonable, but what do you really mean by time? And what do you really mean by spent, right? Or time spent? And then what do you really mean by the database in some sense, right? This kind of begs the question, what is the database, right? And then, is it just processing SQL or is it something else? So we can kind of drill down a little bit more and say, well, it's total, we can answer some of these questions, let's say, and refine our definition by calling it, total foreground time, foreground process time active inside of database calls. Okay, so that sounds a little more precise. Why do we focus on foregrounds? Well, because foregrounds, and maybe I should define foregrounds, we will in the next slide, I guess, but foreground processes are the ones that handle application queries. And so they're the ones that actually do the work. And so that's why we are interested in their time, much more so than backgrounds. Active, so active in a database call. So active means the process is either on CPU or what we call actively waiting. And then in a call means basically between the request and the response, right? So actually we'll see a better diagram in the future. And so the other point that relates to the previous slide is that DB time is not application response time. It's part of application response time, but it's not exclusively application response time. The application does things with data before it actually replies to the user potentially, and then there's always network time that tends to be kind of invisible to everybody, including network administrators. So why do we call it, why do we focus on foregrounds, right? Well, that's because those are the processes in an Oracle database that actually handle the application SQL. And as I said a second ago, it's, the time they spend doing that is part of application response time. It's between, it's after the application has made a request and before it's gotten an answer. Now, backgrounds, there's a whole other set of processes in an Oracle database that we call background processes. And these are basically housekeeping processes that help do the work of the database, the necessary work of the database, but out of band of actually answering application queries, right? So, and I'm not going to get into a lot of details there, but it shouldn't be a foreign concept. But there are these sort of two sets of processes, foregrounds and backgrounds, and they're all using compute resources, and they're all potentially using data, accessing shared data structures and things, right? So we can't ignore the backgrounds. It's really the point I'm making there. But DB time, so formally, is limited to foreground processes, and it's useful to keep that in mind. Okay, so what do we mean by in a database call? Well, basically, clients send SQL into the database, and that gets handled by a foreground session. And the foreground session has to do a lot of work on behalf of, let's say, a random select statement. It has to figure out what's being asked. It has to figure out how to answer the question. And then it has to actually go out and execute its plan for coming up with the answer, right? And only after that can it send back to the application or the client, something, perhaps a pointer to a result set, right? Well, I've got the answer. Whenever you're ready, you can have it, right? So the client receives that and spends a little time and then says, okay, give me some data. So fetch, right? And inside of fetch, you might do more IO, you might do more compute. I should have explained my little diagram here. Compute is represented in green, and IO is represented in blue, and time goes from top to bottom. I should have probably said that too on the diagram. And there's also idle time. Usually idle time is accumulated between calls. When the database, when the foreground is actually finished working on the last request and has sent the response back, well, then it becomes idle until the next request comes. And so we're not interested in calling that DB time because, that's not on the database, right? That part of response time is, that's not part of response time formally. So in a database call, foreground process and active or actively waiting, okay? So active is meaning on CPU or using CPU. And actively waiting sounds like kind of a contradiction. It means ready to use the CPU, but needs some kind of resource, right? So in the example, the simple example, waiting for IO, right? I can't compute until I get the data. Data access is being handled by, some kind of storage infrastructure, and I haven't got it yet. I'm actively waiting. And then there's idle time, and we mentioned this basically. It's between calls. The foregrounds are idle, and we exclude that from DB time. And everyone should be familiar with SQLnet message from client, right? The wait event that accumulates the most time in any database. Well, that's idle time. And then idle time can happen within calls, and it's not as much, but it still can happen. And the most common areas where that's the case is in parallel query. And I won't talk more about why that is now. And then if you're using PL SQL like dbms lock.sleep, that shows up as idle wait, right? So if you've got an application that's littered with lock sleeps, and users complain about response time, it may not show up in your DB time. So this is really the basic model of DB time, right? So it's basically time spent in an active wait or on a CPU. And really the point here is that CPU plus wait time should add up to DB time, when you exclude idle wait, right? So we shove idle off to the side and we say, DB time is CPU plus wait. And it's beyond sort of the scope of this presentation, but it's pretty important to note that this is really a model and thus an approximation to reality. And actually, we're at interesting times now in Oracle technology where the model is kind of, it's breaking down. It's breaking down a little bit because of, kind of advances in technology, basically, the difference between, I'm not going to go into it, but things like PMEM, if you start hearing about that, very, very low latency events that you could subject to instrumentation aren't so subjectable to instrumentation anymore. Let's put it that way. So it's interesting here. So anyway, I won't say more about that. I'm not really going to talk about this because there's not much to talk about, and it's a little bit, but basically it's inside. Everyone should know that there's a shared memory area on the hosts in which Oracle instances run, and there's memory called session state that's allocated on behalf of every foreground process. Actually, it's pre-allocated and foreground process is attached to session state. But basically, that's the location where all of the bookkeeping for this instrumentation, DB time, ASH, and stuff takes place. ASH samples session state and time model and sysstats and are accumulated and written to session state by foregrounds themselves. So I won't say any more about that. That's actually beyond basic. So time model is an instrumentation layer. And it really started in Oracle 7, technically, with Oracle wait events, right? So Oracle wait events go back, kind of before we started talking formally about DB time. And that's part of what I referred to earlier as the evolution of these concepts. So, but I really consider, time model to be a superset that includes the wait events in addition to the technologies that were introduced in 10G with database manageability, which take the form of, or which are in these two views referenced at the bottom of the slide: sys-time model and, well, sys-time model and ses-time model, session and system versions of time model. And then the wait events are in system event, and that's been around for a while. An important point here is that in time model, we have, let's just go see it. So here's one of the few, queries, but this is basically showing you what's in time. Timers, where, activity inside a database call is actually timed by the foreground process itself, right? So when the foreground process, goes into a wait event, it sets a timer. It says, okay, I'm waiting. And then when the wait completes, then it turns it off and says, okay, this is how much time it took, right? And so there's lots of these little timers sort of built into the Oracle code path. But the ones you really are concerned yourself with are the top four here, right? DB time, DB CPU, and background elapsed time, and background CPU time, okay? So, why do we call it background elapsed time and then we call it DB time? Well, DB time is foreground elapsed time, but because it's such an important concept, it got a special name, DB time. And DB CPU, likewise, is foreground CPU time, but it gets the special name DB CPU. And maybe that would be less confusing if we didn't have these special names. But anyway, the CPU thing is actually pretty important. It's not a timer, okay? Oracle doesn't say, oh, I got on the CPU, I think I'll time myself, right? No, what the foregrounds do is they regularly harvest from the operating system the process level CPU stats for themselves. Okay, so they actually gather, they don't try to time how much time they were on CPU. They actually gather how many CPU cycles they used. It's actual CPU usage, right? And it's so the DB CPU number is obtained from the operating system. So in a way, it's kind of an independent instrumentation source from these timers inside the rest of time model. And that's not basic either. So I apologize for that. But here is the most important concept. How much time do we have left? Because we could spend another 20 minutes on this, right? So, yes, sir.
15 minutes.
Yeah, no, I know. I'm just saying. I'll only spend a few minutes on this, but this is really what I want to do is emphasize. This is the most important concept for everyone to understand about DB time, which is average active sessions. Okay. Now, average active sessions is basically a number that we get, or a measure of how much DB time is accumulating in the database per unit of time, right? So you remember when we talked about performance measures, we take like work per unit of time. Well, in this case, we're saying let's take DB time per unit of time. You know, how much does DB time accumulate per unit of time over some time interval, right? It doesn't do you any good to say I got 10 hours of DB time, right? 10 hours of DB time in a month, in a year, in a day, right? So everything has to be sort of expressed as a rate. We also consider average active sessions a measure of the load on the database. It's basically how much work the database is doing over time, right? Averaged. And one thing that often confuses people is because average active sessions has the word sessions in it, it sounds like it should be a whole quantity. Maybe it should be related to the sessions parameter in the initialization file. Well, it's very common for there to be many more total sessions connected to a database at any given time than average active sessions. Why is that? Well, because there's a lot of idle time. There's a lot of SQLnet message from client. There's a lot of foregrounds that aren't doing anything because they've answered the last question and they're waiting for the next question, right? So sessions are often idle. So basically average active sessions is, you know, let's compress all the real DB time down and see how many sessions of work it represents, right? So if I have a database and it has 1,000 sessions connected to it, and the average active sessions is 20, and I have another database and it only has 100 sessions connected to it, but the average active sessions is 40. Well, the second database is doing kind of twice, it's bearing twice as much load as the first one, in spite of the fact that it has many fewer total sessions, right? So one of the things that's kind of confusing, or that takes care, let's say, when computing average active sessions, is that you match the time units, okay? And actually the mismatch in time units was a little bit of a humorous thing when we were trying to actually come up with this name, average active sessions, right? And so we had in 10G a sys metric. So we were measuring database time, and we had all these sys metrics, transactions per second, blah, blah, blah. And so, you know, we did a sys metric out of DB time, right? We're measuring this important quantity, so we divide by seconds, right? So we were measuring database time per second as far back as 10G, but we didn't have the units straight, right? So units were, you know, the database time was measured at that time in centiseconds, hundredths of a second. Now it's measured in microseconds. But we divided by seconds, right? So we were dividing centiseconds by seconds, right? And so we had a mismatch in the time units. Whereas a time divided by a time should be a unitless measure. And the key was, either divide centiseconds by convert either seconds to centiseconds or centiseconds to seconds, but divide by the same time unit, right? But we had a lot of funny considerations on the way to that, right? So, at one point it was like, well, the numerator is foreground centiseconds and the denominator is elapsed seconds. So, maybe we could call it centiusers per second, right? So, because foreground was user time, right? But anyways, basically you can see here, this is a little notebook page. This is a page out of my notebook. I don't have the little thing, but let me put the mouse on it. You can see right here where I wrote down in my notebook, seconds per second equal average active session. And that's basically, that's a meeting notes from a meeting that probably had a dozen people in it, where the whole point was to figure out, one of the whole points of that meeting was to figure out the name for, centiseconds per second of dB time. Tools, basically, average active sessions is basically the basis for most of what Atom does. Atom is automated database diagnostic monitor, basically does a very dB time oriented, expert rules-based analysis of AWR snapshots. And Atom expresses findings. Findings have impact, and the impact is basically how much dB time is involved in this finding. And then for some findings, hopefully most, Atom makes recommendations, and recommendations are accompanied by a measure that's called benefit. And benefit is really how much dB time can be reduced by implementing this recommendation. Excuse me. So dB time is at the heart of Atom. And of course, it's all over an AWR report. Sometimes not so obviously, right? So let's look at this very top section of an AWR report. Well, we can see we have elapsed time and dB time right up there at the top, and they're both expressed in minutes, so the units match. So really, we can divide dB time by elapsed time and get a measure of average active sessions, right? So it's right there at the top, but it's not made so UX lesson here. Since we want to divide dB time by elapsed time, perhaps dB time should be above elapsed time in the report, right? It'd be a lot easier to figure out 0.75 by just dividing 48.79 by 65. Anyway, here you can see the summary section for Atom. This is relatively new in the AWR report. And again, average active sessions is, prominently referenced as the metric of interest for Atom findings. And then down here in the load profile, again, seconds per second equals dB time. Now this is 0.8. This 0.8 is actually this 0.75, right? So it would be actually nice if this went to 2 digits, because then we would see that they're the same number and they mean, and maybe even remember that they mean the same thing. So those are 3 places in the top 3 little sections of an AWR report where you can see average active sessions. Okay, let's talk about ASH. How are we doing time-wise? 28. Okay, we're almost done. Oh, geez. All right, ASH is basically sampling active sessions in the database. If the database session is in a call, and the session is not idle, then we capture state information into ASH. And in the $V view is $V active session history. Everyone should know that. Pay attention to session type and session state, because ASH samples both backgrounds and foregrounds. And so if you're trying to do some kind of dB time calculation, you got to focus on foregrounds. And then ASH makes it easy for you to tell whether session was on CPU or waiting. But on CPU in ASH doesn't mean the same thing as time model. Time model CPU is actually measured to be on CPU. ASH basically says, well, if I'm in a call and I'm not actually waiting, I must be on CPU. So ASH tries to deduce that a session is on CPU. It doesn't observe the session to be on CPU, which is an important point. Okay, estimating dB time using ASH. This is what I call ASH math, right? And this is a really magical process where you're basically counting ASH samples and equating that to dB time. And why does that actually make sense? Well, I like to think of ASH. So ASH samples all the active sessions once a second. And I like to think of it as a movie of what happened in the database, right? Where each sample is a frame. Every second, I have a new frame. And so let's say I wanted to answer the question, well, how many times was, and if I had a movie, how would I answer the question? How many times was actor A in the room or out of the room? Well, I would just count frames and then say whatever my frame rate was times the number of samples or the number of frames. That's how much time they were in the room, in the movie, whatever. So that's what we do with ASH samples. We count samples and we equate it to dB time. And it's exposed in many places. There's a little query here for your, you can just look at it. This is basically showing the SQL IDs with the most dB time. And ASH math is basically shown, it basically, the first place we actually used ASH math in the UI was in the top activity page, right up on the top there. And we still use it in ASH Analytics Load Map. The whole basis for the ASH Analytics Load Map is counting samples and calling it time, but breaking it down by various dimensions. And that's the key thing. In ASH, you have almost 100 different dimensions that we can slice and dice dB time down by. And the thing that's cool about it is, you're aggregating in order to decompose dB time, right? I've always thought that was kind of a neat thing. We're using aggregation to do decomposition. Right. I was going to do a demo, but I don't think we have time. Okay, LinkedIn profile up there, and the only reason I put that up there is not so you'll follow me or something, but because that's where I've got a number of my old presentations that are about these subjects and go into much more detail. So, all right, thank you.
Actually, we have time.
Here.
Actually, we have time for demo if you're ready. Yes. Still have
we do?
10 minutes.
Okay.
Yes.
10 minutes?
10 minutes.
Maybe
yes.
I should go back and talk about some. Oh man, I got so nervous about the time. I zoomed right through it. Well, let's check this out. So I just wanted to do a little Perf Hub demo. Let's see. I've got to sign in. This is when it's really a demo, right? You got to log in. It always helps to have the password handy. Okay, well, here we're logging into OCI. So I don't know if anyone's seen these things, but this is OCI. And what do we want to do here? Why am I not finding what I want to see here? Now you really know it's a demo, right? Trying to find, something's not right. Oh, that's a demo, isn't it? Oh, why is this not playing? See, I'm supposed to have ATPs and ADWs here. I'm not sure why I don't. Ashburn. Let me try this. Yeah, I rushed through. Oh, here we go. Look at that. I'm not sure why that happened. So here we have automatic transaction process. Oh, I don't want service console. No, that's not what I want.
Can you maximize your browser?
Yeah, it's not really. So I don't. Perf Hub isn't here, so I'm not really seeing what I need to see. So I apologize for that.
Okay.
I don't know what that is. Let's go see if there's any good slides I should talk about. Is there any Q&A?
One question.
I'm gonna really check that out. Yeah, I don't see anything. All right, well, sorry I went so fast.
Question is, can't it be wait on CPU?
What's that?
Can't it be waited on CPU? It's very strange.
Yeah, so that's a good question. So waiting on CPU, that's it's a little bit beyond basics, but it's really worth talking about. So in the performance page, we actually use, DB time to deduce that that there was time, database foreground processing time was spent neither on CPU nor in an active wait. And the conclusion is that it must have been on run queue, right? So how do we figure that out? Well, we measure total DB time as the time between the call being made and the request being sent, right? So that's the very coarsest level. And that's really the timing I trust the most, right? It's the beginning and the ending. Now, inside of that time, we have time spent waiting and time spent on CPU. And the time spent on CPU is actual CPU cycles. And the time spent waiting is carefully measured by Oracle and being instrumented. But those things are really history. So we trust the CPU number, and we very much trust the CPU number, and we highly trust the wait time number. And we also trust the total time number. So what we do is we say, okay, let's take the total time in the call from the start to the end, subtract off the known CPU time, subtract off the known wait time. If there's any extra, we attribute that to CPU wait. So CPU wait, when you see it on the perf page or perf hub, CPU wait is deduced in that way from the DB time measures. The total minus the wait minus the CPU. Any left over, we call it CPU wait or run queue. And it's not always, it's actually, let me actually go to another presentation I have, which is where I stole some of the slides for this. But so here was an example. So here's an example. Can you see?
Yes.
So it's taking a long time. So here's an example. All of this light green is CPU wait, right? But it's derived in the way that I said. And there's a huge amount of it, right? So much so that the DBA who was questioning this was really thinking there was an issue with the instrumentation, right? How could there be so much stuff? And he was a very experienced DBA and, tracked it down using, kind of operating system tools. And sure enough, there was a problem with some kind of NUMA setting, which I don't even understand. But, these things have to do with, where things run. And so, basically it was scheduler time. It was time lost in the operating system having to do with, NUMA, process migration or some such thing. So, it's actually a very effective mechanism, but it's not measured. Now, we do have access on some platforms to information of that kind in $OS stat, but it's not always very trustable. And so in the perf page, we do this, total DB time minus known CPU time minus known wait time. Whatever's left over, we call it CPU wait. So thanks for that question. That was a good one.
Actually, you have more questions. So can you go to Q&A?
So I don't know why I'm having such a trouble today. Zoom upgraded, and it seems to be a little different from
Try to open
from what I remember. Maybe if I stop share, then I can see the Q&A. How can we find waiting for CPU? Okay, how do we resolve blocking session issue, please? So blocking session issue, that's why I really wished I could have shown the demo, because the demo was sort of a blocking session demo. If you saw the OCI launch demo yesterday for manageability and observability, that was basically what I was going to demo. Yeah, so Ash is very useful in blocking sessions, because if a session, that's some of the data that Ash captures. If a session is waiting on a resource held by another session, that's recorded in Ash. So Ash is a very good resource for diagnosing blocking issues. GC waits are included in DB time, yes. When response time is significantly greater than DB time, which method would you? Maybe that's kind of something I'd have to think about a little while, more than I can think. If I have 8 CPUs, well, 8 times. For a 60-minute AWR report, and if I have 8 CPUs, will 8 times 60, 480-minute DB time is acceptable. If more than that, we can say that DB time is. So this gets to sort of like the relationship between DB time and capacity on the machine, right? How much load is kind of okay. And, it's sort of, again, it's like everything in our biz, right? It depends. But at a fundamental level, you don't want to really exceed your core count, your CPU usage. So average active sessions on CPU probably shouldn't exceed the core count. If it does, you may be CPU saturated, and you may even be CPU saturated approaching that. So this gets at this sort of the difference between cores and threads, right? But in terms of sort of how much DB time per processing power, it sort of depends on what you're doing. And I would say that as a rule of thumb, you might want to say DB time should be generally less than 2 or 3 times your core count. I don't know why I say that, but that's just kind of something I would say. But again, you want to closely track the CPU, and you want to also closely track what your DB time is all about. So, that's why we worry about, that's why DB time is so fundamental. It's the time that Oracle spent doing work for applications. And so if we can shrink that time down, however we can, reduce CPU or reduce wait, if we shrink that time down and we do the same work, we've improved performance, right? So, the DB time way to approach performance tuning is, look for where there's a lot of time being spent, figure out how that can be shrunk down, right? Why do we go where there's a lot of time? Well, that's where the money is, right? So anyway, will Ash sampling period be reduced? That's a good question. You have the option to do that, and I've never heard of much in the way of people doing that, but you could say reduce your Ash sampling down. But I think this might be a question in response to the concern I mentioned relative to latencies for wait events shrinking very much. And I can't really say whether that, what the impact of that might be on Ash and some other mechanisms. Not because I know and I'm not saying, because I don't know. It's not one of those things. Will the deck be available? Sure. How do we find when it's genuinely on CPU and when it is spinning on CPU? If that refers to things like like spinning on latches and things, Ash can help with that, right? Ash will tell you if it's waiting on a latch and whether a certain, you can figure out whether there's a lot of CPU time spent waiting on certain latches. So maybe that's what that's about. Maybe sharing the demo. I'm not sure what that means. Basically, it may refer to the recording, but the demo I wanted to do, yeah, I don't know, maybe I can make a little screen movie of it or something. There's not much to it, but it's just, I like to show PerfHub. I was using PerfHub for weeks trying to set up for this OCI launch demo. So that's part of the reason why I wanted to show it. I think we've kind of answered a lot of the questions here. 60-minute AWR, if I have a CPU timer. Yeah, we talked about that. Okay, well, let's see what's in the chat here. Oh, see, you know, when I was doing my presentation, I couldn't see any of these things. I don't know.
In the chat, there is
I'm kind of a Zoom dork and a social media dork, so I'm an old guy, you know. All right. All right, well, is that about it? Are we done?
Yeah, thank you so much for being with the tour, and I hope people enjoyed your session and webinar, and they will use this information usefully, I think.
Okay.
Enjoy.
The demo. I'm actually going to zoom right in on that right now and figure out what happened, but it's too late to do anything about it. Thanks again.
Yeah.